Okay, boys and girls, today, before we move into our next unit in math, we're going to review how to add and subtract fractions and how to multiply fractions. So you should have your math notebook. If you don't, go and get that. And I want you on your next clean page, no cheating, to turn your notebook sideways and make just a two-column chart that have these two headings. On one side, add and subtract fractions, and the other, multiply fractions. Once you're ready, I want you to take about a minute to pause my video, and I want you to see how many rules or steps or things that you remember about adding and subtracting fractions, and then the same for multiplying and dividing fractions that you remember, because they're not the same, and some of us maybe are forgetting these things already. So take a minute, go ahead and pause me, see how many you can come up with, and then check in with me when you're finished. Okay, so your lists should look very similar to this. We wrote these down as we were learning these two concepts. So remember that when you add and subtract fractions, you have to have common denominators. And when you multiply fractions, you do not. Once you make your common denominators using that least common multiple, so remember multiples are always skip count, we're finding the lowest one that they share. And sometimes you can multiply them together to find the LCM. Remember, you could always multiply the denominators together, but it might not be your simplest form, so you might have more work at the end to do. So you make your common denominators, and then when we add and subtract, I should have put or subtract, we only work with the numerators, which is different when we multiply. When we multiply both the numerator and the denominator. If we have mixed numbers and we're adding or subtracting, we can simply just add or subtract the whole numbers as just a separate part of the problem. But when we multiply, you cannot do that, because remember, we've talked about this so many times when we have our math talks and you decompose numbers to be able to multiply more easily. Let's say it's 21 times 11. You decompose that 11 into both a 10 and a 1. You have to multiply the 20 by the 10 and by the 1 because you're multiplying all the parts together. If we were adding 21 plus 11, we could decompose both of those, 20 plus 1 plus 10 plus 1, and you're just adding all the pieces together. So it is different when we add and multiply. So make sure if it helps you to think of how we're multiplying with whole numbers for number talks, then apply that here. Remember, these patterns and things are really the same between whole numbers and decimals and fractions. Okay, we have to multiply all the pieces and the parts together. So we have to make them improper fractions. When we add and subtract, the denominator stays the same. Since we're only working with the numerators, the denominators, remember it to be super lazy when we add and subtract, and they just kind of they tag along at the end. But not here. So we're multiplying the numerator and the denominator, and then we're simplifying in the end. When we simplify, we're not using multiples, the skip counting, we're using factors. The factors are the numbers that make the two numbers we multiply together to make the product that we see. So if they share a 2 in common, if they share a 4 in common, then we're simplifying by that. I did have several of you leave your final answers on the test as improper fractions. And remember, that is not what we're doing. You cannot leave something as 26 fifths. Okay, if you end up with an improper fraction and you think that you're finished, you then need to convert that into a mixed number. All right, we're gonna go through a couple examples. I expect you to write these down and solve them. Do not just wait for the video to come back and check your answers. We're gonna start with 3/4 plus 2/5. So whether you have room on that page you just wrote on or go to the back, that's fine. Write this down, and we're gonna follow these steps. We have to have common denominators. So we're going to make common denominators using the LCM. So that's a least common multiple. So when we think of 4 and 5, we skip count by 4 and 5. What number do we get to first that they both make? This one hopefully is a little bit easier. Remember, fives, you can only make numbers that end in zeros and fives, right? And so when we multiply things by 4, you're not going to end up with the 5. You're going to end up with a 0, perhaps. So we kind of can narrow this down, maybe even without writing a list. You could write your list and skip count by 4. Remember, I asked you to go usually to about 5, and then you can stop unless you find a number. But if we know that we end in 5s and zeros, we could maybe just skip count by 4s and see when is the first time we end in a number with 0 or 5. So if we skip counted by 4s, we'd hit 20, and we can know pretty easily that 5 will make 20. So in this case, our common denominator is using the two denominators multiplied by each other. So to get 20 using 4, we multiply by 5, and whatever we do to the bottom, we do to the top, because we have to keep that equivalent. 5 over 5 is the same as 1. So 3/4 times 1 is still 3/4. We're just making it look different, but the value is the same. Over here, to make 20 using a 5, we multiply by 4, and we then do that to the 2 as well. And we're going to add. So boys and girls, some of you just skip this part and maybe write some things down. When I'm looking at your work to try and help, maybe I don't know where your number came from. I don't know what you used. Some of us maybe aren't always the best at our math facts yet. So if you write down what you multiplied by, I will know maybe it's just a math fact problem versus you don't know how to solve the problem. So what I have on the screen is exactly what should be in your notebook. And I don't care, you guys, how awesome at math you think you are, or how awesome at math facts you are, or how fast you can do whatever with math. You need to write it down. Period. End of story. We've talked about this all year. Some of you are still giving me grief about that. Please, please, please write it down. So we add across the top, and that denominator stays the same. I think sometimes our issues when we're missing these problems just comes from this basic addition. Okay, so make sure that you are taking your time to add correctly. If you don't know what 8 plus 5 is, well, if you take 2 from 15 and give it to the 8, compensation, you make that a 10. If I took 2 from here, that's 13. 13 plus 10 is much easier to do in your head, so that's 23/20. So here we have our final answer. However, it is as an improper fraction. We don't ever want to leave it as an improper fraction. Because our numerator is bigger than our denominator, we look at this, remember, fractions are division, as 23 divided by 20. Please don't just write this as a long division problem, right? 20 and 23 are really close. So writing it as a long division problem, 20 won't go into 0, and you're still going to end up dividing into 23. Okay, so in this case, it's not really going to help us. If we have 23 markers laying on the ground, how many groups of 20 can we take out? Just one big group. One group of 20. So we have now removed 20 from that pile. How many are left? 3. And that denominator still stays the same. All right, I'm going to put one up here. I'm going to give you mixed numbers, and I want you to pause me and try to do it on your own. Let's go with 2 2/3 plus 1, and we'll do 1/6. All right, pause me and work that out. Okay, you should have ended up with 3 5/6. So here you can see my work. It's always great when one of the denominators will make the other, so you don't have to do quite as much work. So 1 and 1/6 stayed the same, and we made the 2/3 into 4/6. You could have multiplied the 3 and the 6 and gotten 18. You're going to end up with 3 and 15/18 though, and both of those share a 3. That is not something that students often think of, so many just think that it's simplified, but it's not. So try to use the LCM and have your lowest multiple as you can. So you can see here that I just added the two whole numbers, and I added the numerators, and that denominator stayed the same. All right, subtraction works the same. So we still need to have common denominators. We have 6 1/4 minus 2 5/8, so write that on down for me. We're going to find common denominators here. So the 4 can be made into an 8. 6 2/8, and then this mixed number is going to stay the same, minus 2 5/8. So here's where we have to stop, pause yourself, and check to see, is this going to work for me? Can I subtract the fractions as they are and have a positive number outcome? Sometimes the answer is yes. Here the answer is no. 6 minus 2 works just fine. However, if we get into subtracting the numerators, this doesn't work. 2 minus 5 will give me a negative 3, and I'm not wanting a negative answer here. So please remember that subtraction is not commutative. Someone raise your hand and tell Mrs. Hope what commutative is. Commutative means that we can switch the order and get the same answer, right? So this is not it. Subtraction is not commutative. So we can't just say, oh, well, I'm just going to make this work. 2 minus 5 is 3. Nope, doesn't work that way. So here's where we have to regroup, just like with whole numbers. We regroup. So we're going to think of this 6 as a 5 plus a 1, right? We're just going to decompose, and that 2/8 has to be there as well. So you always just want to take one less because the 1 is now needing to be written in fractional form. Whatever your denominator is what you're going to make that 1. So 8/8 because 8 is my denominator. So I have 5 plus 8/8, which is 1. So that still equals my value of 6 plus my 2/8. So altogether I have 5 and 10/8. Many of you have understood this and you say, oh, I'm just going to take one away from the whole number and add a group of the denominator up here to the top. And that is totally fine. If that's how you think about it without writing all this out, that's okay. Some of you know that you need to make the 8/8, but you don't reduce this whole number. And so oftentimes your answer is 1 more than it should be because we didn't reduce this. So make sure as you regroup, you take 1 off of that first whole number. So my 2 5/8 is still hanging out here. This feels like a lot of work. So remember, don't just stop here. We didn't actually do the subtraction yet. And now we can go back into, we subtract the whole numbers, we subtract the numerators, and the denominator still stays the same. So if you need to pause and look at that and talk through it for a minute with your classmates, go ahead and do that. And then I'm going to put one up here for you to solve on your own. All right, I would like you to try 3 2/5 minus 1 7/10. Jot this down on your paper. I want all of your work written. And then turn me back on when you're done to check your work. You should have gotten 1 7/10. So we made common denominators as 10. Hopefully you didn't do 50. So we ended up with 3 4/10, and then I noticed that numerator 4 minus 7 isn't going to give me a positive answer. So if 3 is the whole number, we reduce it by 1. So 2 plus 1, we're decomposing. And don't forget that fractional part, right? It wasn't just 3 whole things we're taking from. There's 3 plus a little more. So that fraction has to kind of join it. So your 1 that you're regrouping uses the denominator 10 to make a fractional 1, 10 over 10. So I still have the same value. 2 plus 1 is still 3. And then add that 4/10 in. So 2 14/10. Now when you look here, you see 14/10, that's an improper fraction, right? So that's more than 1, which is why the value stays the same. I could take a group of 10 to make a 3 and I'd have 4 left over. I'd come right back to this fraction. That's why it's equivalent. So now I have a numerator big enough to take from. 2 14/10 minus 1 7/10 is 1 7/10. All right, we're moving right into multiplication. This should be super duper fresh in your minds. Remember, we do not have to have common denominators. So the very first thing, if we have mixed numbers, is not to multiply 1 times 3. If you look at this and you say, oh, that answer is 3 and 2/15. No, that 1,000%, if you have multiple choice on something, you guys, will be one of the answers. Those types of answers were all over your math test last week. Okay, and some of you chose them. It's not trying to trick you. It's simply trying to see, do you actually know that you can't multiply only some parts of a problem together to get an answer? Okay, and that's what I did. 3 times 1 is 3, 2 times 1 is 2, 3 times 5 is 15. That would be 3 and 2/15. But that doesn't work. I have to take 3 times the 1 to make 3, but then also take a fifth of 3. Okay, so we have to do all of this rolled together. That is where we've talked about changing these into improper fractions. We multiply the denominator by the whole number, add the numerator. So we had our little swirl here that I know a lot of you liked. That denominator is still going to be there. It's going to be the same. Okay, denominators really truly are pretty lazy. Okay, so in most fractional work, so I know I'm going to have a 3 and I know I'm going to have a 5. So that's really easy to put down and then you don't confuse them. Some of you changed your denominators through your work on your test, and that maybe is why you missed some things. So here we go. 3 times 3 is 9, plus 2 is 11, and then 5 times 1 is 5, plus 1 is 6. Okay, now we can multiply straight across. 11 times 6 is 66. 3 times 5 is 15. So I have to think, my next step is simplifying. So how do I know if I'm going to just reduce the numbers by a common factor or if I need to divide this out to get a mixed number? Well, an improper fraction, which is what this is, it has a bigger numerator than denominator, means it is more than 1. So this should tell me I need to divide top down, right? I divide like this, top down, 66 divided by 15. Now, boys and girls, here's what I was saying earlier. If you have, whether you do a box or a bracket, right? I'll just do a box just so you can see. It's the same if you have a bracket. It doesn't matter. You should look, 15 isn't going to go into that first number, right? 15 doesn't go into 6. So your 6 is coming over here and you're still just dividing. This is 66 divided by 15. 66 divided by 15, which is what we have here. So all of this is really unnecessary to write down because it's not helpful to you. If this was 662, then yes, right? Because 15 has to first go into 66 and then the 2 is going to join in. So kind of look at that. Some of you are writing these things down. It's just kind of taking more of your time than needed because it's not really truly going to help you. So we need to think about our 15s. Some of you are trying to do this in your head, and while that might work for some of you really truly don't do this. Okay, I don't want those long lists. I've asked you not to do that. Do 2 at a time if you need to add. It's okay if you're doing this. There's 1, there's 2, here's another one. Please do it step by step by step because some of you need to do that. You're missing when you're trying to add and do too much in your head. Okay, I can get the same effect by taking the time to add them here as skip counting by 15s if you know them. That's fine. Okay, so 4 15s is about as close as I'm going to get, right? That's 60. So I have 66 markers on the ground. I'm trying to take big chunks of 15 out. So how many big groups of 15 am I going to have? 4 whole groups. So I was able to take 60 out. How many do I have left? 6. That denominator stays the same. Okay, so now I have to see, can I simplify this? Well, what numbers make 6 and 5? What factors, or not 5, 15. So I can multiply 1 times 6 and 2 times 3. For 15, I can multiply 1 by 15 and 3 by 5. Do they share anything other than 1? Yes, they share a 3. So I can divide these even by 3. That whole number is still going to be there. 6 divided by 3 is 2. 15 divided by 3 is 5. And so 4 2/5 would be the final answer. All right, write this down. 2 1/2 times 1 3/4 in your notebook. And I would like you to pause me while you work it out and then check in when you're finished. All right, so your final answer for this should be 4 3/8. So if you convert your mixed number, you should have 5 halves times 7/4. Then we have to multiply correctly. Once or twice we had numerators that were 5 times 7. I had several people write 40. So make sure, especially those 5s, you guys, you can use your finger skip count and make sure you have the right multiple. So 5 times 7 is 35 and 2 times 4 is 8. So here I have an improper fraction. And what does that mean? That means this is more than 1. So I can divide to make a mixed number. So how many 8s can I get before I hit or go over 35? Skip count by your 8s and you should come to 32. So 4 groups of 8, that's 32 that I'm taking out of that big chunk of 35, and I have 3 left over. So that is my numerator, and then my denominator stays the same. If I wasn't sure if I could simplify this or not, I can write my factors for 3 and 8. I multiply by 1 times 3 to make 3. And for 8, I multiply 1 times 8 and 2 times 4. The only things they share are 1s, which wouldn't be helpful, right? Because we would end up with the same number. So other than that, there are no shared factors. So if there are no common factors, that means that this is in simplest form. So you know that you're done. Oops, simplest would be nice if I spelled it correctly. Okay, boys and girls, so that is your review for the day. Take your notes, use your notebook. You have a math mystery that you're working on today. So use all of the things, not your neighbor. Use all of your tools and your resources from today and through the last 2 units that we've worked on together in your notebook to figure out the mystery.